Yes, in this lecture, we will discuss a design of footings. So, design of footings on safe software. So, in the previous lectures, first we completed slab design. So, next it will be beam design, column design. So, after that, the final step will be footing design. So, for slab, beam and column design, we used ETABS. For footing design, we will be using SAFE. So SAFE, it will be developed by CSI, Computer and Structures. So SAFE, it is specially designed for structural engineers focused on foundation design. Okay. So its capabilities are design of slab systems and foundations. So SAFE, it will be used for design of slab systems and foundations. Okay. So in SAFE, you can design PT slabs also, post tensioned concrete slab design. You can integrate with ETABS for seamless workflow. So you can integrate with ETABS. Okay. So today we will be discussing design of footings. So this is your ETABS model. For the footing design, you need support reactions. To view the support reaction, go to plan view, base, apply, OK. So these are your column locations. You just go to display, force bar stress diagram, support reactions. Here you take dead load plus live load. So click on apply, OK. So these are your support reactions. So these support reactions in ETABS are with respect to a global axis. So these reactions are with respect to global axis. So here Fx, Fy and Fz are forces, Mx, My and Mz are your moments. Okay, so Mx and My are moment about global X and Y axis. See here, so this is your global axis system. So X, Y and Z will be, so this will be our Z axis, and out of plane, so Z will be out of plane or along gravity direction. Gravity direction. So for any fixed support, you have 6 degrees of freedom, 3 translational and 3 rotational degrees of freedom. So you can check here, assign, go to assign, joint, you select any joint. So let me unlock the model. So go to assign, joint, restraints. See here, if you select fixed here, so there will be a 6 degrees of freedom. So 3 translational and 3 rotational about global axis. So before going to footing design, you should run analysis and complete the slab design, beam design and column design process. Okay, so go to display, force bar stress diagram, support reactions. See here. So out of 6 reactions for footing design, we need Fz, Mx and My. So I will turn up only those reactions, turn on. So I don't need Fx, Fy. I need Fz, Mx, My. I don't need Mz. Okay. So go to apply. Okay. See here. For footing design, I need 3 components. So one is Fz. So Fz is your gravity loads. Okay. Mx and My. Mx and My are moments about global x and y axis. Okay. So footing design will be carried out on 2 steps. So first step will be fixing sizes for footing. Fixing sizes for footings, which means length of the footing and width of the footing. So your second step will be deciding the thickness. So thickness of footing. So as I told, footing design will be carried out on 2 steps. First initial step is fixing sizes. Second step will be deciding the thickness of footings. So for this project, we assume SBC, safe bearing capacity of soil, as 200 kilonewton per meter square or 20 tons per meter square. Okay. So first we will take up fixing sizes for footings. Okay. So first you go to display, force bar stress diagram, support reactions. For fixing sizes for footings, you need support reactions for service load combination. So your service load combination is dead load plus live load. So you just click on apply. Okay. Okay. So these are your column numbers. So these are your column numbers. So here column number 4, it will have same FZ as well as column number 56. Okay. So this will be F1 and this will be also F1. Same axial force and same moments. So here 8 and 60. So I will take it as F2. F2. Next 12 and 32. F3. Next 16 and 40. F4. So next it will be 20 and 48. So F5. Okay. Next, so this will be individual. F6, F7, F8, F9 and F10. Okay. So I need 10 sizes, or you can reduce it to 5 or 6. So totally I have 10 groups. So F1 to F10. Okay. So let me take a screenshot. So SPC is 200 kilonewton per meter square. So I have prepared a Excel sheet. So first I will find out the initial sizes. So I will just copy this file. So these are my initial groups. So first F1. So FZ is 290, MX is 7.2. So for this footing, so F1, FZ will be 290.37 kilonewton. Mvex will be 7.24 kilonewton meter. My will be 1.65 kilonewton meter. So these are support reactions at service load combination. So dead load plus live load. So based on these reactions, we will find the initial sizes. So I will go to my Excel sheet. So here FZ, so it will be 290.37. So 290.37. So multiplied by self weight of footing. So it will be taken as 10% of axial load. So it will be 1.1. So for this axial force, I will add 10% as weight of footing. 10% as weight of footing. So I multiplied this value with 1.1. Okay. So MVEX 7.24. 7.24. MY 1.65. 1.65. So 1500. See here maximum pressure and minimum pressure. Maximum pressure and minimum pressure. So here maximum pressure, it will be calculated as P by A plus MSXX, which means moment at service loads along XX divided by ZXX plus MSYY divided by ZYY. So ZYY and ZXX are section modulus. Section modulus. So for any rectangular or square section, so Z section modulus, it will be BD square by 6. You should remember this formula also. Okay. So this is the formula for P max, maximum pressure. So similarly P minimum, pressure. So it will be P by A minus MSXX divided by ZXX minus MSYY divided by ZYY. Okay. So P max should be less than your SBC. P minimum, it should be greater than 0. So then the assumed size is correct. So your maximum pressure should be less than your SBC. Your minimum pressure should be greater than 0. Okay. Then the assumed size is correct. See here, for these analysis forces, so I taken size 1.5 meter, which means 1500 into 1500 millimeter. So maximum pressure 157, minimum pressure 126. So my SBC is 200. Still I have the chance to reduce the size. So I will go by 1200. Okay, 1200 will not work. So 1300 by 1300. So it will also not work. So I will go with by 1400, 1400. See here. So for size 1400 by 1400, your maximum pressure it is 182, which means it is less than SBC, and your minimum pressure which is greater than 0. So then this size is okay. It can be okay. So I have prepared a Excel sheet. Okay, or you can use the calculator. See here. So first for maximum pressure P by A. So that is 319.40 divided by area 1.4 into 1.4 plus moment 7.24 divided by BD square by 6. So 1.4 into 1.4 square divided by 6, again plus 1.65 divided by 1.4 into 1.4 square 1.4 into 1.4 square divided by 6. See here, it will be 182. So in the Excel sheet also same answer 182. For P minimum, so it is very simple. In the above equation you use negative sign. So which will be P by A 319.40 divided by area of footing 1.4 into 1.4 plus 7.24 divided by 1.4 into 1.4 square divided by 6. Sorry, it is P minimum, so I have to use negative sign here. So next minus 1.65 divided by 1.4 into 1.4 square divided by 6. So it will be 143. So P max and P minimum. Clear? So for footing F1 group, so size will be 1.4 into 1.4 meter. So I will note down the sizes. So for F1 it will be 1400 millimeter into 1400 millimeter. So this is length of the footing and this will be breadth of the footing. Okay. So similarly for F2. So for F2 374.68 374.68 multiplied by 1.1, which will be self weight of footing. So 10%. Mx and My. So it will change 4.12 4.12 and 0.073. So 1400, 400 it won't work, so I will go with 1500, 1500. See here, for F2 1500 by 1500. So F2 size 1500 millimeter into 1500 millimeter. So next F3. So F3 it will be 479. 479.68. So otherwise I will copy this to on my Excel sheet. Okay. So now it is easy. So now I am calculating the sizes for F3 footing, F3 group. So 479 multiplied by 10%, it is self weight of footing. So next 3.91 moments and 2.12. See here, 1500, 1500, it won't work. So next size 1600, 1600, it won't work. 1700, 1700. Yes. So for F3 group, 1000. So for F3 group, so it will be 1700 multiplied by 1700 millimeters. Okay, so this is my F3. So next to F4. So F4 it is 540. 540.38. So MXX it will be 3.91, 1.03. So 1700 it won't work. So 1800, 1800. So for F4 group it is 1800. So F4 it is 1800 millimeter multiplied by 1800 millimeter. So similarly for F5. So F5 it is so for F5 group it is 320, 320.05, 7.20, 2.65. See here, if I take 1800 by 1800, it will work. So your maximum pressure is 118. So which is much more less than your SPC 200. So I can still have the chances to reduce the footing size. I will go by 1200, 1200. So it won't work. So what is the next size? Next size is 1400 by 1400. So I will go with 1400, 1400. See here, it won't work. So next size 1500 by 1500. So 1500, 1500. So my F5 will be, so my footing size Fy will be same as F1. So F1 and Fy are same. Sorry, I think it is 1000. What is the size? 1500 by 1500. So then it will be F2. F2 and Fy are same. So this is my F1 size. So F2 and Fy are similar. Next F6. So for F6 it is 453. 453.06. So x direction movement 0, y direction 1.02. So 1500, 500 won't work. So after 1500, which is my size, 700 and 800. So I will go with 1700, 1700. Yes, it will work. So for F6 also 1700, 1700. So F3 and F6 are same group. So next F7. So F7 it is 520. So 520.32. MX0 MY it is almost 0, 0.303. So 1700, 1700. So F7 also same size. So F7 same size, 1700 millimeter by 1700 millimeter. So next it will be F8. So 647. 647. So moments MX0 MY 1.489. 1.489. So 1700 won't work. So next 1800. 1800. It will also won't work. So I will go with 2000. 2000. See here. So for F8 it is 2000 by 2000. So next group will be F8. So 2000 millimeter multiplied by 2000 millimeters. Okay. So next F9 and 10. F9. So F9 725.90. 725.90. MX0 MY 0.755. So 2000 won't work. I will go with, so it is slightly less than SBC. So I will go with 2000, 2100, 2100. So 2100 by 2100. So it is F9. So my F9 group size is 2100 millimeter multiplied by 2100 millimeters. Okay. So next to last F10. So it will be 493. So axial force is 493. MX0 MY 1.79. See here, 2100, 2100. So for these axial force it is a huge size. So my first size is 1400. So I will go with 1400, 1400. so it won't work. Next 1500, 1500, it won't work. So next size will be 1700. Yes, 1700 by 1700. So my F10 footing, my F10 footing, it will falls in this category. So I have 6 sizes. So first is 1400 by 1400. Next second size will be 1500, 1500. Third size it will be 1700. Next 1800, 2000, 2100. So total I have 1, 2, 3, 4, 5, 6, 6 sizes, or you can combine any two and you can make it 4 or 3 groups. Either you can F8 also you can go with 2100 by 2100. For F1 also you can go with 1500 by 1500. Okay, so I will take the screenshot of this. So these are your initial sizes. Okay, so we'll copy the same screenshot. So these are my final sizes, not final. So now I will take you to save. So once you analyze your ETABS model, you can import this ETABS model to your save. So first you go to file, export, click on export, story as safe version 12.f2k file. Okay, so here story to export, you should select base. So loads to export, you should select this option, export floor loads and loads from above. Okay, next load cases, so you select dead load and live load, click on OK. Load combinations, you select two load combination. One is your service load combination, dead load plus live load, and your ultimate load combination is 1.5 dead load plus 1.5 live load. You just click on OK. Click OK. So it will ask you to save. So I will save it as footing design F2K. So click on save. Yes. Okay. So once you export this ETABS file as F2K file, you just minimize your ETABS screen and you go to save. You click on new model. So metric SI Indian IS 456 2000. So click on OK. So here you select blank, click on OK. So once it is open, you close this model explorer, you go to file, import safe.f2k text file. So this is your .f2k file, footing design. You click on this, open. See here, same ETABS grids are imported to safe. So to see the column points, you just go to set display options. You uncheck this invisible, apply, OK. Okay. So I will use split screen option. See here on the left side, I have my ETAB screen. On the right side, it is my safe screen, safe software screen. So here horizontal grids are in ETABS. Horizontal grids are named as A, B, C, D, E. In the safe also, same grids are imported, A, B, C, D, E. So your vertical grids, I will turn off this support reactions. See here. So your ETABS grids, vertical grids are 1, 2, 3. So in safe also 1, 2, 3. So these are your column points. So these are your column points. Okay. So this is how you can export your ETABS model to safe for footing design. So I will minimize this ETABS screen. So this is the same grid system as in ETABS. So same nomenclature also. Okay. So these are your column locations as in your ETABS model. Okay. See here, one thing you need to remember here. So in ETABS, your load cases are named as dead and live. You are analyze your structure only for gravity loads. So you have two load cases or load patterns, dead and live. When you import your ETABS model to safe, so these dead load pattern, it is renamed or named as dead above in safe. Same in ETABS, your live load pattern, it is named as live above in safe. So these are your load patterns. So in ETABS, your load patterns are dead and live. When you import your ETABS model to safe, so in safe, same dead load pattern, it is named as dead above. So live load pattern, it is named as live above. Okay. So you go to, so I am working in safe software. So go to display, show load assigns, joint. So here load pattern, you select dead. So first you save this file, footing design. See here, In safe, you have dead above and live above. So these are nothing but ETAFs dead and ETAFs live. So whenever you select dead above, see here. So these are the reactions. So for this footing, your dead load reaction is 423. So you can check the same in ETAFs also. You go to ETAFs, go to display, force bar, stress diagram, support reactions, case you select dead, shear. So you have same value 423.91. See here in safe also same 423.91. So for this footing 460. So this is 460. Next 562. So here 562. So this is for dead load. If I see for live load, so here you go to display, support reactions. In case of load case, you select live. So here you go to display, show load assigns, joints. If you select live above, see here in ETAPS it is 29.15. In safe also same 29.15. So same support reactions are exported to safe. Okay. So this is how you can verify. Okay. So next step will be in safe. You go to design, concrete slab or beam design, view bar revise preferences. So here you should select code as IS 456 2000. So next material safety factors for steel it is 1.15, for concrete it is 1.5. So you go to minimum cover for slabs, even though here it is written as slabs, but it will be applicable for footings also. So for clear cover, for footings clear cover will be 50 mm, clear cover bottom again it is 50 mm. So preferred bar size, so I will go with the 12 mm diameter. So minimum cover for beams, it is okay, let it be 50 preferred bar size. For flexure I will go with 16. Preferred bar size for shear it will be 8. You just click on OK. Okay. Next, go to define material definition, material properties, add new material, Indian concrete. You select M25 grade concrete. So it is same as ETAPS. So 25 density of concrete. So here grade of concrete M25. So concrete cube compressive strength it is 25 Newton per mm square. Click on OK. Click OK. So you have M25 grade concrete. Next, add new material. Go to rebar. You select HYST grade 500. Click on OK. So here you change the density 78.5. So click on OK. So you have two material properties M25 and HYST 500. One is concrete, another one is steel. You click on OK. Okay. So once you define material properties, so one is you defined M25 grade concrete, and Fe 500 steel. So it is same as ETABS. Okay. So next step will be footing thickness. So you define, go to define. So to define the footing thickness, you go to define section property, slab section, add new property. So here thickness of the footing. So I will go with, in the beginning I will go with the 300 mm thick footing. So slab material M25, modeling type shell thin. So here in case of property data, so type you select footing, so thickness 300, you just click on OK. See here, so you have footing size 300 mm, so click on OK. So next, to draw the footing areas, so you go to this option, quick draw area around point. So your property, footing property is F 300 mm. See here, you know the sizes. So F1 is 1400 into 1400 millimeter. So this footing F1 and this is also F1. So you go to save. So dimensions 1400, 1400. You just click on this column center. So these are footing F1. So next F2. So this footing and this footing is F2. So F2 size is 1500 by 1500. So 1500, 1500. So this footing is F2 and this is also F2. And F5, F5. So these two footings are also 1500. So this is also 1500, 1500. So next F3. So this column and this column F3, 1700 by 1700. So you change the size here, 1700, 1700. So 1700. Next F6, F6. So this 1700. Next F7, F7. This also 1700. Next F10. So this also 1700. Next F4, 1800 by 1800. So 1800, 1800. Next F9, F8 and F9. F8 2000. So 2000 by 2000. So next this will be F9. F9 it is 2100. So 2100 by 2100. Okay. See here. So this is F1, F1. Next, this footing belongs to group F2. These two footings, F2. Next, these two belongs to F3. Sorry. I think I left one grid. So this is F1, F1, F2 group, F2. So this is F3, F3. Okay. Next, so these two are F4, F4. So this is F6, sorry, F5, F5. Next, this is F6, F7, F8, F9, F10. So according to sizes, F1 is 1400 by 1400. F2 and F5 are same. So these F2, where is F5? So these four footings are same size. So 1500 into 1500 millimeter. Next F3. I will change the color. So these F3, F6, F6, F7, F10 have same sizes. 1700 multiplied by 1700. So F4. F4 means these two footings. 1800 multiplied by 1800 millimeter. Next F8. So this will be 2000 multiplied by 2000 millimeter. Next this group 2100 multiplied by 2100 millimeter. So for all the footings, I have taken depth as 300 millimeter. So this is not the final. This is my initial depth for all the footing. So the depth it is 300 millimeters. Okay, so we'll minimize this. So once it is done, so our next step will be, so select all the column points. So only select all the column points. So you go to design, concrete slab or beam design. In case of punching check overrides, so here you select location type as interior. You just click on OK. Okay. So next you select all the footings. You go to assign joint floor meshing options. you select this option, you check this option, include selected joint objects in mesh, click on apply, okay. Okay, so here you need to define modulus of subgrade reaction. So next you need to define modulus of subgrade reaction. Okay, so it is nothing but stiffness of soil. So you have the formula F equals K into delta X. So F is your bearing pressure, and delta X will be your settlement. So you remember allowable settlement for footings, so which will be 25 mm for general buildings. So this is the allowable settlement. So in this case, I know the bearing pressure SBC of soil. It is 200 kilonewton per meter square. So if you use this formula F into K delta X, so F is 200 kilonewton meter square equals K into, so delta X, it is 25 millimeter. So if you convert this value to meter, 0.025 meters. So K into 0.025 meters. So you will get K as 8000 kilonewton meter square per meter. So this is your modulus of subgrade reaction. So how to define this on SAFE? So you go to define, spring properties, you select area spring, add new property, so modulus of subgrade reaction, which is denoted by K. So your value is 8000. So modulus of subgrade reaction, so here it is 8000. Okay, so you click on OK. So next, how to assign this value to footings? So you click on display, show undeformed shape. So you select all your footings, you go to assign, shell, area spring. So you have the spring property 8000, you click on apply, OK. Okay, so go to display, show undeformed shape. So you select any one footing and click on right button, see here. So spring, it is assigned as 8000 and you have the thickness 300 mm. Okay. So next step is select all four corners of each footing. So select only corners. Don't select your column points. You select only corners. You go to assign, joint, restraint. So here you restrict translational X and translational Y. So you click on apply, OK. So next option will be meshing. So you go to analyze, automatic mesh setting for floors. Here you use the mesh size as 0.25 meter. You click on OK. Okay. So you select all your slabs. I think you need to change the rebar material. Go to design, concrete slab design. Where it is available, change rebar material. In case of design, see here, yes, it is there. Go to design, concrete slab design, view bar revise slab flexural design overrides. You click on finite element based. So here rebar material. So your grade of steel is HYST 500. So click on OK. Then you go to run analysis. So it is preparing to analyze. So once the analysis it has been done, the first and foremost check is check for soil pressure. Check for soil pressure. So for load combination, dead load plus live load, which means service load combination. Service load combination. So your soil pressure should be less than your SBC, which means 200 kilonewton per meter square. So how to check soil pressure? So you have a great option in SAFE. You go to display, show force bar stress diagram. You click on soil pressure. So load combination, you should select service load combination DL plus LL. So you click on apply. OK. Okay. So you just zoom in. You just use your mouse cursor. It is showing values 169, 170. Okay, this footing size is okay. Similarly, you need to check for all the footings. So my SBC is 200. So your soil pressure should be less than 200. It is around 170, 178. Okay, 176. For this footing it is 177, 150. So for this middle row it is 164. Okay, it is 188, 187, 170, 174. So 170. So none of the footing it is showing more than 200. So 140, 175, 176, 177. See here, my footing pressure is less than, soil pressure is less than SBC. So which means I can say whatever the sizes I have chosen are correct. So here negative sign, if you see, if you move your cursor, so here negative values indicates compression. So negative sign indicates compression. If I have any positive values, it is nothing but your uplift. Okay. Or else you go to display, show force bar stress diagram, go to soil pressure. So you give the range minus 200 to again minus 200, maximum and minimum range. See here, okay. So here minimum range minus 200, maximum range plus 200. You click on apply. Okay. See, if you see the contour here, any value which is in this pink region, it is negative, minus 200, which means this magenta color indicates your soil pressure is, so this magenta color, this is minus 200, and this dark blue, so this dark blue color is plus 200. So if you scroll for values, none of the footing it is showing pressure more than 200, and none of the footing it is showing uplift also. All values are in negative sign. Okay, so my footing sizes, whatever the sizes I have chosen, are okay, or passed the soil pressure check. So next step will be, deformed shape or deflected shape. Deflected shape. So my assumed settlement is my assumed settlement is 25 mm. So for which I need to refer load combination dead load plus live load. dead load plus live load. So you go to display, deformed shape. So combination, dead load plus live load. You click on apply, OK. See here magenta color is minus 23.5. My assumed settlement is 25. Again you zoom in, you scroll for values. UZ, you check deflection along UZ direction. It is minus 20, minus 19. It should be less than 25 because your assumed settlement is 25, and you need to check this deflected shape for service load combination, which means your load combination will be dead load plus live load. Don't check your deflected shape and soil pressure for ultimate load combination. So please remember, soil pressure check and deflected shape check. It should be for service load combination, that is DL plus LL. Okay. So here the values are, deflected shape values are less than my assumed settlement. I have assumed the settlement as 25 mm, but my actual settlements are less than the assumed. Okay. So you can say my footing sizes are correct. So whatever the sizes I have taken are satisfied my soil pressure check, and deflected shape or deflection check, or you can say this as settlement. So if these two criteria are satisfied, then the assumed plan sizes, footing sizes are okay. In the beginning I told that footing design, it is carried out on 2 steps. So footing design, it is carried out on 2 steps. One is, so first step is fixing sizes. Fixing sizes for footings. Second one will be depth of footing. So fixing sizes means length and breadth of footing, and depth of footing means whenever I say depth means it is nothing but thickness of footing. So footing design, it has been carried out under 2 steps. Fixing sizes will be the first, and the next one will be depth of footing. So footing sizes, it is governed by soil pressure, your soil pressure and settlement, whereas depth of footing, it is governed by shear, which means one-way shear, and two-way shear, which means punching shear, and flexure. So out of these 3 criteria, the critical will be one-way shear. Okay. So in this lecture I completed fixing the sizes. Okay. In the next lecture, I will take up how to decide the depth of footing. So what are my footing plan areas? So you go to display, undeformed shape. So you just unlock the model. You go to draw dimension lines. See here. So this footing is 1.4 meter, 1.4 by 1.4, and this will be 1.5 by 1.5. This is 1.7 by 1.7, and this will be 1.8 by 1.8. You go to options, graphic preference, you change the graphic font size. So this footing again 1.5 by 1.5. So this will be 1.7, 1.7. This footing 1.7, 1.7. This is 2 meter by 2 meter. So this footing it is 2.1 by 2.1. So I think why it is 1.75. Let it be. Oh, I made a mistake while drawing the dimension lines. It should be 1.7 by 1.7. Yes, 1.7 by 1.7. 1.4, 1.4, 1.5 by 1.5, 1.7 by 1.7, 1.8, 1.8, okay. So these are the footing sizes. So till now we decided only length and breadth of the footing, that is plan sizes. So which is governed by soil pressure and settlement. Then we need to decide thickness. So thickness of the footing which is governed by one-way shear or punching shear. So shear, which is nothing but one-way shear, this punching, which is nothing but two-way shear, and flexure. So out of these three criteria, so critical will be one-way shear check, which means for all the footings I have taken depth as 300 mm. So I need to check whether this depth will satisfy these three checks. If not satisfied, again I need to increase the depth of the footing. So my plan dimensions are okay. So whatever the sizes, these sizes are correct, which means these sizes as satisfied two conditions. One is soil pressure check, another one is settlement check. So this I have completed. In the next video I will take up this, how to decide the thickness of the footing.